Good evening, good morning, good night, wherever you are. What you see before you is a output in Pygame of a little simulation I've got going in the background. I became a little bit interested a week ago about modeling, seeing other people model pandemics on YouTube, in fact. And so I decided to give it my own sort of spin on it, and in doing so, I felt like I learned a lot. So I'm back here trying to share the the information is showing before you. Takes a bunch of houses, which in this case is 25,000, populates them between 1 to 5 meeples, we're going to call them, that then will wake up every day and get to go out to a random number of businesses between 1 and 5 again. If they go to a business where a infected person has independently chosen to go to that business, then there's a risk of infection for all the non-infected meeples that go to the same place. This is primarily how meeples get infected. At the end of the day, though, when they go home, there's a risk of it spreading between everybody that lives in their house. This sort of parallels the real world, where you have your random chance of encounter would be the same as randomly going into the wrong shop and catching the disease, with how also a disease spreads amongst people who are familiarly tied and know each other. Though saying these are just toy models, they're not here for they're not perfect like the real world. They don't necessarily have all the exact numbers and variables plugged into them like the real world is. I've done a little bit of trying to match and work out how reasonably a flu spreads, so the numbers aren't bizarrely too high, say, or too low, but your given mileage may vary. So the reason for doing this is maybe we will get some insight. I felt like I gained a lot of insight in having done this. Having felt like I looked through this, I felt like I learned a lot about how the model works. So the screen that I'm moving on to is showing the change in rate over time. As you can see, you've got this nice white line is the non-infected. This grey line is the immune, and the red is the death rate. So as you can see, on the scale of the whole population, the death rate is a very small percentage, and often is even with really lethal viruses and lethal pandemics, because whatever it is just a percentage of this grey line. So in this case, it's 1% of this grey line. There's an interesting thing that causes pandemics to stop, and it's worth talking about. As we start off, if you're an infected person, you are going to go to a business, and everybody you meet is not going to be infected. So there is a very high chance of you going out and infecting more people, relative to whatever infectiousness that the virus you carry has. But as time goes on, you get more and more immune people in the population. There's less people in the population that haven't already had it. Therefore, at that point, your percentage of passing on the virus becomes a combination of not only your chance to infect a new person, but the chance that that person is not already immune. And if they are already immune, you've not passed it on. And an interesting thing with living creatures and their evolution is, if it doesn't survive and doesn't pass on its genes, that's it. That's the end of that that branch of that tree. So what often happens is as the virus is propagating in the population, it reaches a point where its chance of spreading what they're calling the news the R0 value drops below 1. So at the beginning, a pandemic has to be spreading from one person to spread to a multiple of others. It could be 1.1, it could be 2, but it has to be greater than 1. It wouldn't be a pandemic if I went out and only infected one other person. It has to be an infectious agent that goes out and infects, say, 2 or 3 or even 1.1. But as soon as it drops below 1, well, say it was 0.9, is that what we're actually saying is there's a 90% chance that I'll infect somebody new, but there's a 10% chance I won't. And that means inevitably at some point in that cycle, I'm going to fail to infect the next person. So I do have to break these videos up to comply with YouTube's guidance and rules. I've got a few other videos to go through different scenarios and to talk about different ways of doing this. As you can sort of see, to talk about the pandemic, endemic, and recovery phase, this number of infected at the very beginning starts much higher. It starts at 100, it balloons up to 300, say, but at a certain point, it stops carrying on going up, and it just starts to shrink. And it gets from 300 down to 148, and it'll carry on going down until it disappears. It disappears from the population. So that's my first video. I hope you'll join me in the next one, where I'm going to discuss about the financial sides of things and what we could do to make that number of infected people go down shorter in a smaller time frame and reduce the impact of this virus. Thank you.